Longitudes and latitudes. The Earth. The Earth is a vast universe with a circumference of about 25,000 miles. There are so many places on the surface of the Earth, and the dilemma is how to specifically locate each one of them. For instance, suppose I want to give the direction to the specific position of this bridge in San Diego. To find the specific location of a place, the parallels of latitudes and meridians of longitudes are used. Latitudes. The lines of latitude circle the Earth from east to west. They are of same distance apart at 69 miles. Each degree of latitude is separated into 60 parts called minutes. There are 60 minutes in 1 degree. Further, each minute is divided into 60 parts called seconds. The equator lies at 0 degrees halfway between the north and south poles. Other unique lines of latitude include the Tropic of Cancer, which lies 23.5 degrees north, and the Tropic of Capricorn, which lies the same degrees south. The part of the Earth between them is called the tropics. The position is given north or south of equator in terms of the angular distance. From this figure, R is 60 degrees north, written as 60 degrees N. S is 50 degrees south, written as 50 degrees S. Note that the position is measured along a meridian. Longitudes. The lines running north and south are called the meridians of longitudes. Just like latitudes, the longitudes are measured using degrees, minutes, and seconds. Longitudes are, however, not equidistant from each other. They intersect at the north and south poles. The 0 degrees longitude is called the prime meridian, passing through the Royal Greenwich in England in the United Kingdom. Meridians whose positions are given east or west of the Greenwich meridian are called longitudes. It's the angular distance from the Greenwich meridian along the equator. Positions of points on the Earth's surface. The position of a point on the surface of the Earth is given by the intersection of the latitude and longitude. The latitude is given first. From the figure below, the following points can be given in terms of their position as below. A is 50 degrees north, 60 degrees west. B is 60 degrees south, 60 degrees west. C is 50 degrees north, 70 degrees east. D is 60 degrees south, 70 degrees east. E is 0 degrees, 60 degrees west, which means E lies on the equator. The radius of the Earth reduces as one moves away from the equator. All latitudes other than the equator are called small circles. The radius of the Earth is, however, constant along all meridians. All meridians are great circles. the distance between 2 points along a great circle. All longitudes are great circles. Only one latitude, that is the equator, is a great circle. The distance between 2 points along a great circle is measured in kilometers or nautical miles. 1 nautical mile is the length of an arc subtending an angle of 1/60 of a degree, or 1 minute on the center. If a distance of 1 nautical mile is covered in 1 hour, the speed is said to be 1 knot. It follows that 1 minute is equal to 1 nautical mile. This is shown below. Generally, if an arc subtends an angle theta at the center, then the arc length is given by theta times 60 degrees. For example, find the shortest distance between each of these pair of points. Give your answer in nautical miles. A, 45 degrees north, 40 degrees east, and B, 15 degrees north, 40 degrees east. It means point A and B are along a latitude 40 degrees east. The angle subtended is given by 45 degrees minus 15, which is equal to 30. This is because both points lie on the same side of the equator, that is 45 degrees north and 15 degrees north. The arc length is therefore 30 times 60, which is 1,800 nautical miles. P, 0 degrees, 40 degrees east, and Q, 0 degrees, 55 degrees west. This means point P and Q lie along the equator. However, P and Q lie on the opposite sides of the Greenwich meridian, and therefore the angle difference between them is the sum 40 plus 55, which is 95. The arc length is therefore 95 times 60, which is 5,700 nautical miles. Distance in kilometers along great circles. Consider the figure below. The small arc PQ subtends an angle theta. PQ is equal to theta over 360 2 pi r. The radius of the Earth is approximately 6,370 kilometers. The distance between point A, 0 degrees 30 degrees east, and B, 0 degrees 10 degrees west, will be given by the angular distance is 30 plus 10, which is 40. Then we have 40 over 360 times 2 times pi times 6370, giving us 4,448.89 kilometers. Converting kilometers into nautical miles. We've seen the angle of 40 degrees is subtended by an arc of 48.89 kilometers. This is equivalent to 40 times 60, which is 2,400 nautical miles. Dividing the distance in kilometers by the distance in nautical miles, we get 1.8537. Thus, 1 nautical mile is equal to 1.8537 kilometers. Conventionally, 1 nautical mile is equal to 1.852 kilometers. Distance along small circles. Consider the figure below. MQ is a small circle with center N and latitude theta degrees north and a radius of small r. RP is a great circle that is the equator with the center O and a latitude 0 degrees and radius capital R. OQ is equal to OP, which is capital R, and OP is parallel to NQ. Hence, angle NQO is equal to angle QOP, which is angle theta. This is from the alternate angles property. From the right-angled triangle ONQ, cos theta is NQ over OQ, which is small r over capital R. Thus, R is equal to capital R cos theta. Thus, the radius r of a small circle is equal to the earth radius r times cosine of its latitude. For example, the distance between P 60 degrees north, 10 degrees west and Q 60 degrees north, 35 degrees east. The angular difference is 10 plus 35, which is 45. R is 6370 cos 45, which is 3185 kilometers. The arc length will therefore be equal to 45 over 360 degrees times 2 times pi times 3185, giving us 2502.5 kilometers. Time and longitudes. The Earth rotates through 360 degrees every 24 hours. Therefore, 1 degree is equivalent to 24 times 60 over 36, which is 4 minutes. Thus, any 2 points along the equator, 1 degree apart, have a time difference of 4 minutes. Places on the same longitude have the same time. Those on different longitudes have different times. The Greenwich local time is called the Greenwich Mean Time, or GMT. The Earth rotates from west to east. All points west of the Greenwich have their local time behind the GMT. All places east of Greenwich have their local time ahead of GMT. A point east of another is always ahead of the second in time. For example, the local time at P 0 degrees 25 degrees east is 2:20 a.m. on Sunday. Find the local time at another point Q 0 degrees 75 degrees west. The difference in longitude is 75 plus 25, which is 100 degrees. The difference in time is 100 times 4 minutes, which is 400 minutes. 400 minutes is equivalent to 6 hours and 40 minutes. Note that Q is behind P by 6 hours 40 minutes, and therefore the time at Q is 7:40 p.m. on Saturday.
If you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs. And once it starts going downhill, you're in trouble.